Greetings everyone, my name is Miljen Sirotić. I am a research fellow at the Foscari University of Venice. Thank you for providing us with the opportunity to present our research study results on the International Maritime and Port Technology and Development Conference and the 4th International Conference on Maritime Autonomous Surface Ships, held in Singapore from April 6 to April 7, 2022. Our research study focuses on achieving green and sustainable seaport transport systems via enhancing multimodal transport options for passengers. Pivotal reasons fostering such research endeavors are rooted in the fact that environmental concerns are a profound and essential component of passenger seaport sustainable development, which brings up the necessity to address ports from the green port's perspective. Contemporary notions and definitions of the green port refer to a seaport comprising of a sustainable environment, fair use of resources, low energy usage, and low emissions. In order to develop a better understanding of the issues associated with global maritime transport CO2 emissions, it is necessary to comprehend the relationships between seaports and transportation modes' energy consumption. Thus, improving the environmental impact of passenger seaports must be achieved via a holistic methodological approach by examining the consequences of CO2 emissions of the entirety of water and land transport modes intersecting at seaports. Pivotal elements indispensable for the creation of the entirety of the selected water and land transport modes CO2 emissions inventories in passenger seaports consists of the two main characteristics: technical characteristics and operational characteristics. Technical characteristics of transportation mode entities represent a significant and major factor regarding carbon footprint calculation in passenger seaports. The main reason for such claim is that different technical characteristics of transportation modes entities provide different outcomes regarding carbon footprint emissions. Main elements of technical characteristics of transportation mode entities encompass gross tonnage, length, breadth, engine power, and fuel type utilized. Operational characteristics are of great importance as well, because passenger timelines for each individual transportation entity differ substantially, which results in variance in carbon CO2 emissions due to different speed distribution at certain route sections and different propulsion machinery load. A deeper insight in the map leads to the conclusion that the evaluation and comparison of the selected water and land transport mode CO2 emissions is conducted on the geospatial area of the Middle Adriatic. The passenger seaports of Ancona and Zadar are considered as final points of origin and destination. The port of Ancona is located in the middle of the Italian Adriatic coast, precisely in the Gulf of Ancona. Contemporary perception of the seaport is the notion of being one of the significant Middle Adriatic seaports for the European Union's motorways of the sea traffic in the eastern Mediterranean. The port of Zadar is a deep water port and represents the most significant economic and business zone in the Zadar county. The new passenger port Gaženica is located near the center of the Zadar city, which is one of the most attractive tourist destinations of the Middle Adriatic. The transportation mode distance lengths are presented in the table next to the map. By observing the information within the table, it can be concluded that the railway transport mode infrastructure is the longest in terms of kilometers, the road transport mode infrastructure holds second place in terms of kilometers, and the maritime transport mode holds third place, meaning it is the shortest in terms of kilometers. It is important to note the distance lengths of the examined transportation modes because distance length is a crucial factor in determining the CO2 footprint of any transportation mode. Before you is a table and a graph both representing the evaluation and comparison of the selected water and land transport mode CO2 emissions on the route between the passenger seaports of Ancona and Zadar. The maritime transport mode holds the status of reference regarding passenger capacity of all transportation modes in terms of origin-destination selection. The service vessel designated for the operation of the Ancona-Zadar passenger shipping line between the two Middle Adriatic ports is the Ro-Ro passenger ship Zadar, holding the actual and reference capacity of 1,109 passengers. A deeper insight into the table and the graph leads to the conclusion that the CO2 emissions of water transport mode, by estimating the emissions of the ro-ro passenger ship sailing at open sea and hoteling at the seaport, result in the fact that the hoteling times CO2 emissions are 24% higher than when the ship is sailing at open sea. Furthermore, the assessment of land transport modes provides a conclusion that passenger automobiles holding 20% capacity represent the least environmentally favorable transportation mode option. When at full capacity, passenger automobiles possess higher environmental efficiency than passenger trains and the ro-ro passenger ship. However, passenger buses hold the status of the most environmentally efficient land transport mode, provided that they operate at full passenger capacity. Passenger trains are the most environmentally efficient only when they operate at full capacity and when other land transportation modes operate within a value range of 20 to 80% of capacity. To conclude, in terms of greening passenger seaports, this study provided the CO2 emissions of water transport modes and land transport modes. It can serve as a baseline for a detailed carbon footprint emissions inventory for designing effective measures to reduce emissions of water transport modes while sailing at open sea or hoteling in ports, and for land transport modes on land transport networks. It can provide maritime governmental authorities with better decision-making capabilities regarding the adoption of technical and operational policy perspectives. Technical policy perspectives are static because they envelop transportation entity elements that cannot be subjected to substantial changes once implemented on the selected transport modes. They can be subcategorized into four main elements: hull type and chassis extensions, power generation systems, types of fuel utilized, conventional or alternative, and the last one, the fourth one, propulsion systems of transportation modes. Operational policy perspectives are dynamic because the change in economic and environmental circumstances dictates their conditions. They can be subcategorized into three main elements. First one being specifics of transportation modes, itinerary and schedule. Second one being velocity alterations of transportation modes. And the third one, and the last one, transportation modes engine power load alterations. It is also important to note that maritime governmental authorities can further reduce the carbon footprint of water and land transport modes by complementing the aforementioned two perspectives of policies with active travel measures of being cycling and walking, by changes in the built infrastructure such as LNG and cold ironing facilities installation, and by the implementation of smart information communication technologies.
Thank you for the presentation. Hi, Mija. Hello.
Hello. Hello.
Hi, welcome for joining us online. Any questions for the presentation? For the presenter, sorry. We heard quite a lot about shipping and ports in this session, and I think this talk relates also to the comparison with the land transport mode. Okay.
Hi, good morning. So I have one question to you is, have you considered the impact of traveling time? That means the difference of land traveling time versus sea traveling time. And if, let's say, the difference is very significant, then have you considered the monetary value associated with the time traveled?
We thank you for asking the question. We have taken into account such multi-objective parameters, and they will be addressed in the future research. But I also believe that they are very crucial elements in determining and making better policy, evidence-based policies for the decarbonization of the maritime sector.
That means at the moment it's not yet included, not yet considered. Am I right? To clarify?
Yes.
Or not yet?
Yes,
Okay.
yes.
Thanks. And I have one question as well. You mentioned about carbon emission reduction and the monitoring of it and then the policy implications. Can you explain some more how can your model or the study be used by, let's say, policymakers and some other stakeholders? Explain some more?
Well, they can use a map as a detailed graphical interface, which they can use to determine the length and the time needed for the ships and other transportation modes on their routes, which can then be assessed to strategically coordinate their flotilla or vehicles in order to achieve better sustainable solutions. And they can also include the passenger capacity of such fleet and vehicles and determine the optimal vacancy rates that are necessary to provide better carbon footprint reductions.
Thanks. Any more questions?
Yeah.
All right. So then, thank you, Miljen, for joining us. And then this is the end of this track. Thank you very much.